video we are going to talk about circles. Will talk about arc length and sector area and two questions regarding the same topic. So first let's see what is arc length and sector area and how to calculate it. This is the center of the circle, the black spot O. From this point to the circumference becomes the R. These are the two R's or the two radius we see. This is the arc length, the green thing which you can see. And the quarter circle which you are seeing this part over here, I'll show you also this thing. This all becomes the sector, or you say the area which we have to find, the sector area. So the formula of arc length is theta upon 360 into 2 pi r. What is theta? This angle which is formed between the two radiuses, and the sector area formula theta upon 360 into pi r square. Again theta same thing, and r we know. These two formulas are very important for the understanding of our other questions. Let's look at this example. We have the 12 centimeter as the radius and 140°. I'll just let you know one thing. This point over here is the center of the circle, and the angle we are talking about is over here, and the arc length we have to find is AB, and that also minor AB. Just add right it, minor arc. Now why minor? Because it is less than 180. This angle is less than 180. If you will take and use another color, this angle, this will be greater than 180. So this AB would have become major arc. Write it, major arc. So you have to be careful what it asks. If it asks for minor arc, you have to use 140. If it asks for major arc, you have to use 360 minus 140. So for this question, it's asked for minor arc AB. It's an example for arc length. So you understand how to use the formula. Formula was theta upon 360 into 2 pi into r. R is to be same given to us, which you get 29.3 cm. And sector area of the same AB 140 upon 360 into pi r square, 12 square. So we get this as the answer. Don't forget the unit centimeter square over here. Now it's not always that you have to directly find arc length or sector area. It may be like it is given to you the arc length and you have to find the radius. So simply you have to substitute it, like make the r the subject of the formula. As simple as that. Let's move on to the question. Question 1. Finding the shaded area, that is this pink region area you have to find. So you can see over here, this is 5 centimeter entire thing, and this is 4 centimeter till this point, and the entire is 5 centimeter. If you have to find this area, you have to subtract the bigger sector area minus the smaller sector area. I'll show you over here. So I've just labeled the bigger sector as A, smaller sector as B. So area of sector A, which is this entire thing, I have drawn here a rough diagram to avoid confusion. It is 5 centimeter as the radius. It becomes 90 upon 360, it's right angle, into pi r square. You get is 98.63 centimeter square. Similarly, area of sector B, which has the radius as 4 centimeter. The uh, the angle is still 90. So it becomes 12.57 centimeters square. You can directly put this value into the calculator. Shaded area is A because it is the bigger one, minus B the smaller one. 19.63 minus 12.57. Now here I've written 3 as the correct answer according to what dp you are taking. Here I've rounded it to 2 dp, so I was getting 7.06. You may get 7.07 if you don't round it to 2 dp. So this was our first question. Let's move on ahead. The second question is a little tricky. It says a bicycle wheel of radius 10 centimeters turning at a rate of 5 revolutions per minute. Calculate the distance moved by a point on the rim in 2 seconds. So you need to focus while understanding this. This is the bicycle wheel, and over here the 10 centimeter radius which it is talking about. So we'll go step by step. When the wheel rotates one revolution, the point of the rim will travel a distance equal to the circumference of the circle or the wheel, you see. So I'll show you this thing also. Maybe this is a start point. It goes around, it goes around, it comes back to this point. This would be called as a one revolution, and this is also equal to its circumference. So the distance traveled from one revolution is 2 pi r. This is nothing but the formula of the circumference. We have r as 10 cm, so we use it. I'm not converting pi to our decimal using more decimals. So we get the distance for one revolution time pi cm. Now the wheel rotates 5 revolutions. It's going to the question over here. 5 revolutions per minute. So the distance in a minute would be 20 pi into 5, that is 100 pi cm. Okay, so for 1 minute the point travels 100 pi cm. So distance in just 2 seconds, we want in just 2 seconds. So 2 seconds is nothing but 2 upon 60, 60 is a minute. So 2 upon 60 I did here into 100 pi, I get 10.47. The final answer is this. So this is how you solve this question. Understand it once again or repeat it. Repeat the video. So let's move on to the last question for the day. The length of an arc of a circle is 7.5 cm. The corresponding sector area is 37.5 cm square. Find the radius of the circle and the angle subtended at the center of the circle by the arc. This is a bit tricky question, you may think, but if you understand the question step by step, it's becoming very easy. So the corresponding sector area means at the same sector area. Okay, so let's look at it simply and carefully. Let x represent the angle suspended at the center of the circle. Okay, we have a circle. I will draw the example of the circle on the side over here. We have this circle over here. We have the center over here. We have this over here. We have this angle which I have labeled as x. We have the arc of the circle, that is 7.5, and we also have the area, that is 37.5. This is the basic structure. Now let us move ahead. So the area of the sector, which we have given 37.5, would be equal to x upon 360 into pi r square, right? Simple formula I've used. Just x and r are the two variables. We have the area of the sector given to us 37.5, so I use it over here. Let's make r square the subject. That's what I've done here, taken entire thing down. This I am labeling as the equation 1. I'll write here for those who don't know this, equation 1. So now Looking at this equation 1, you may have thought of one of the previous videos which I had made on simultaneous equations. So that's exactly how you have to do this entire question. Let's look ahead. Arc length. So definitely for simultaneous equation you need two equations. Another thing given to us is arc length. So we'll now handle with this. X upon 360 into 2 pi r. Simple formula. We have 7.5 x equals upon 360 into pi into 2r. We'll make r the subject, right? Because in the earlier question we have earlier equation, sorry, we have r square, so r. So I simply take x upon 360 into pi down over here, and this 2 also you have to take on the other side. Now here I have written half. Why, I will tell you that also. So I will do it over here. So this is 2, so it will get divided by 2, right? So I have this, I will label this as, I will labeling this as maybe a, okay? So it will go as a divided by, okay, a upon b. I have two things, so I will do a upon b divided by 2. So this is not possible in fraction. You have to do reciprocal of this. So I did a upon b into half. That's exactly what I've done over here, into half. And this 1 1 nothing, but here 2 2 we get half, so simply I've done that same thing, same concept. Half the 7.5 gives 3.75. Cool. Let's move on. Now if you see at equation 1, we have r square, so simply I have squared on both these sides. So 3.75 the whole square x upon 360 to pi the whole square equals to r square. Now equation 1 and equation 2 both have r square, so we can equate them. So I've done this over here, equated both of them. Now we can cross multiply. That means, what does this simply mean? Taking this over here and taking this over here. So we are cross multiplication. So after cross multiplication, we get these as the value. 3.75 square into x upon 360 into pi equals to 37.5 bracket open x upon 360 into pi square. Now we can see both as x upon 360 into pi, x upon 360 into pi. So we can divide both sides by x into 360 into pi. So that we get rid of this square which we don't want. So we get 3.75 square equals to 37.5 bracket open x upon 360 into pi bracket close. So simply now 3.75 square, you square it, you get 14.121 dB if you do it. And over here I can take x out, so 37.5, I have taken this value of pi 3.14 into 360. I will perform this calculation if you want to. So it is something like this. If I write it, you'll understand easily. Okay, correct. Over here, something like this. So x pi upon 360. So I will do it. So these things I will have to erase this. I have no other space. So I will erase this entire thing, and I will get here x pi upon 360. Now what you have to do? You have to take x out and this has to multiply. So this also again has 1 over here obviously. So simply this multiplies with it. 47.5 multiplies with this pi and the x comes up. This is exactly what I have done over here. Okay, okay, got it. Now let's move on. So I'll calculate this, put it on a calculator, you get the answer and make x the subject. 42.97 equals to x. So we got the x was the angle subtended. So we got the answer for the B1. So this is the answer for B. Now it's all simple. After getting x, only substituting is left. Substitute this x over here or over here, anywhere you like. Preferably this. Y to handle squares. After you substitute, making r the subject, obviously over here you have to make r the subject. You will get r as 10. Simple substitution is this. So you got the A answer also. So both the answers solved. This was an interesting question, number complex question, but these kind of questions you have to be ready to answer. Let's move on to the end of this video. Thank you so much for watching. See you next time.